Envision a colossal social affair, played by an unending number of stars, planets, and moons, all playing together sublimely. However, there is one unequivocal part of this troupe that has stunned space experts for a truly critical time span: exoplanets. These are ordinary planets that exist outside our planetary framework, stowed away somewhere deep in the Milky Way. You may be shocked to find that, among the enormous number of cosmic objects, there are exoplanets so like Earth, so tantalizingly similar yet confounding, that they may be our planet's heavenly twin. We dive into the enchanting space of Proxima B, found 4.2 light-years away. The James Webb Space Telescope is revolutionizing our journey to understand these heavenly mysteries. Envision a moment when your mind ventures across the vast immensity of our galaxy, the Milky Way, which is home to more than a quadrillion exoplanets. That's a number with 15 zeros. To put this into perspective, if each of these exoplanets were the size of a grain of sand, we wouldn't just fill the Grand Canyon. We'd have enough to create another landmark on Earth, a Grand Canyon 2.0 stretching for a tremendous distance. It is astonishing that around 20% of these celestial bodies are designated as Earth-like in terms of geology and atmospheric structure. This means there is a 1 in 5 chance of encountering a twin of our planet. And the story doesn't end there. Alongside these planets, there could be another quadrillion moons, rugged satellites like our moon, caught in a gravitational dance with their parent planets. If you've ever dreamed of discovering another body in space that harbors life, or could do so, the universe offers a surge of possibilities. Now that we've laid out this grand cosmic scale, it's time to introduce the expert tool prepared to explore its intricate details: the James Webb Space Telescope. This eminent instrument, with its enhanced focal lens and adjustable focal centers, surpasses even the most advanced optical devices. Its 6.5-meter primary mirror, 2.7 times larger than Hubble's, can capture exquisite detail, even from the faintest burst of a star billions of light-years away. Can also analyze the intricacies of orbiting planets. What makes the James Webb Telescope revolutionary isn't just its power but also its advanced technology. Equipped with state-of-the-art sensors and spectrographs, it does far more than observe. It analyzes. It deciphers the light signatures emitted or reflected by celestial objects, revealing their chemical composition, density, and even mass. Acting as a space detective, it can determine whether a planet has water, organic compounds, or even oxygen. The James Webb Space Telescope represents more than a mere evolution of its predecessor, Hubble. It's a quantum leap forward. If Hubble's discoveries amazed us, the Webb Telescope promises a genuine celebration of celestial revelations. As we broaden our gaze across the complex landscape of the universe, it's worth focusing on one specific star in the cosmic symphony: Proxima B. Since its discovery in 2016, this mysterious planet has captured attention like a Shakespearean hero, full of unpredictability and intrigue, fascinating astronomers and anthropologists alike. Why all the excitement? First of all, Proxima B is practically in our galactic neighborhood, just 4.2 light-years from Earth. To put this into context, if you could break the universal speed limit and travel at the speed of light, you'd arrive in just over 4 years. About the same time it takes for your favorite show to fall into reruns. But let's dive deeper into why this planet is so important. We're talking about a universe stretching over 93 billion light-years from end to end. Finding a planet so close and so ripe for scientific exploration is like discovering a gem in a mountain the size of Everest, a diamond that potentially holds secrets about existence itself. In the grand tapestry of the universe, Proxima B is a fascinating thread, offering enormous clues that could reshape how we understand habitability and life beyond Earth. It's not just Proxima B's proximity to Earth that excites seasoned scientists, but also the tantalizing signs that this planet may not only be Earth-like but potentially Earth 2.0. Proxima B lies comfortably in what astronomers call the habitable zone of its parent star, where conditions are neither too hot nor too cold but just right for liquid water to exist. Imagine waterfalls, meandering streams, vast lakes, and perhaps oceans as deep and mysterious as the Mariana Trench. Yet, before we start dreaming of visiting Proxima B, we should consider some of its peculiarities. A single day on this captivating exoplanet lasts an astounding 11 Earth days. Imagine sunrises that not only herald a new day but unfold slowly, refusing to give way to evening, and sunsets that linger for hours, creating golden hours that photographers would envy. While this sounds idyllic, it has significant implications for its climate and habitability. How would human biorhythms adjust to such extended patterns of light and darkness? Would we need to eat 3 or 4 times as much in a single day on Proxima B? Would we sleep the same way? The fundamental rhythms of life, as we know them, would be simultaneously familiar and utterly alien. It's as though nature has handed us a riddle wrapped in an enigma, challenging our understanding of what makes a planet livable. You may wonder how we can gather accurate and reliable data about a world we've never visited. The James Webb Space Telescope uses its myriad capabilities like a giant Swiss Army knife. It's more than just a telescope, it's a sophisticated research laboratory in the vacuum of space. Thanks to its innovative technology, astronomers don't just observe planets. They analyze them through a prism of scientific instruments that would make even the most advanced CSI labs seem basic. Using advanced spectrographs, the Webb telescope can dissect the light emitted and reflected by these distant planets. Every element or compound in a planet's atmosphere absorbs or emits light at specific frequencies. By focusing on these patterns, scientists can perform a remote biopsy of celestial bodies, determining atmospheric pressure and density, as well as the possible presence of compounds essential for life, such as water, organic carbon molecules, and even oxygen. Space science isn't just astronomy, it's cosmic forensics. We don't passively wait for clues to come to us. We actively seek them out, analyzing the atoms and molecules that make up these intricate worlds. The Webb telescope isn't just an eye in the sky but a highly specialized research lab, detective, and cosmic investigator, all in one. It allows us to transform our speculations about alien worlds into actionable scientific discoveries. Verify or refute them. Changing comprehension, we might interpret what could exist past our blue spot. Right when you assumed you had uncovered the most shocking layers of this cosmic onion, the story goes off in a strange direction, very much like in any sci-fi thrill ride. Researchers utilizing the James Webb Space Telescope got something astonishing from Proxima B. A signal so dumbfounding that it spread all through the academic corridors and virtual entertainment. Named as a potential tech signature, it was an electromagnetic release so complex and intricately planned that it could indicate the presence of an advanced civilization. The collective heartbeat of humanity seemed to stop at the pinnacle of a discovery that promised to reshape our perspective on reality. Could the signal be the genuine proof that we are not alone in the universe? And just as quickly as it appeared, the signal vanished without continuing, abandoning not only a stunning silence but also a labyrinth of unanswered questions and bubbling theories. Was it merely a transient cosmic anomaly, a random event of infinite chance, or something more deliberate, a coded message or even a sign of extraterrestrial intelligence? The single mission cast a lingering shadow of mystery over Proxima B, igniting wild discussion and speculation. Was it just a passing peculiarity, or is it part of a much bigger story, more puzzling than we can imagine? But wait, the story of our vast exploration is far from over. The ink has not yet dried, and new chapters are still being written. This time, not only are traditional experts but also Harvard researchers leading a paradigm shift. As we continue the search for extraterrestrial life, they are not content with studying the signals and anomalies we've encountered thus far. They are raising the stakes by transforming the James Webb Space Telescope into a sort of giant night vision telescope. They intend to search for artificial light sources in both the dark and illuminated regions of distant worlds. We're looking at stunning possibilities, such as detecting artificial versions of cities glowing in the dark like bright beacons. Imagine seeing the glowing light emissions. It could be a city humming with the presence of an advanced civilization, sending its glow into the vast cosmic oceans. As we continue unraveling the mysteries of the universe, the quest for extraterrestrial life takes on new dimensions. Beyond the immediate intrigue in Proxima B, our grand curiosity delves deeper into the vast new regions of space. This pursuit is driven by both technological advancements and an insatiable desire to understand our place in the universe. Advances in astronomy and space exploration have led to the discovery of numerous exoplanets with potential habitability. Instruments like the James Webb Space Telescope, biosignatures, and ground-based observatories have expanded our ability to detect and study these distant worlds. One particularly fascinating area of study is the search for biosignatures, signs of life. These could include atmospheric gases like methane or carbon dioxide, which, under the right conditions, could suggest biological processes. The JWST's capabilities extend beyond basic discovery. Its advanced instruments can measure the atmospheric composition of exoplanets, helping scientists pinpoint potentially habitable worlds. The data gathered by the telescope could reveal the intricate processes and dynamics of distant exoplanets, unlocking new insights about their environments. With our exploration efforts continually advancing, Proxima B remains a key subject of inquiry, guiding us into the future of space exploration and extraterrestrial life discovery. As the James Webb Space Telescope expands our understanding of distant planets, the search for life beyond Earth has become a central focus of scientific inquiry. The technology and techniques we're using to examine these exoplanets, such as measuring their atmospheric composition, can provide the most direct evidence yet of whether they could support life. This mission isn't just about seeking Earth-like biological conditions, but also about considering the vast diversity of conditions that might allow life to emerge in unexpected forms. Discovering extraterrestrial life, or even signs of life, carries profound implications for humanity. It challenges our perception of ourselves as unique in the universe, expanding our understanding of life's possibilities. Imagine discovering that life has evolved elsewhere under conditions vastly different from Earth's. Could life on other planets adapt to extreme temperatures, toxic atmospheres, or a lack of water? Could it survive in environments we once thought inhospitable? These questions push the boundaries of science, philosophy, and astronomy. Proxima B, with its potential for habitability, serves as a beacon in this quest. Even if life doesn't exist on Proxima B, the very possibility of habitability opens doors to exploring other star systems that could harbor life. As we continue gathering data from this distant exoplanet, we are also learning about the broader universe, refining our tools and techniques to detect life across the cosmos. One of the most exciting prospects is the possibility of discovering biosignatures or technosignatures, indicators that life might be present or that an advanced civilization could exist. While scientists remain cautious about drawing conclusions from odd signals like the one from Proxima B, the search for artificial light or other signs of technology could revolutionize how we think about extraterrestrial intelligence. The idea that we could detect cities or infrastructure on distant planets opens up new avenues of inquiry, blending astronomy with the search for civilizations beyond our own. This dynamic, ever-evolving exploration is driven by collaboration across many fields: astronomy, science, engineering, and artificial intelligence. As technology continues to improve, our ability to survey the universe with ever greater precision will only increase. New missions are already being planned to take advantage of the Webb telescope's capabilities, with future projects aiming to study even more distant exoplanets and star systems. What does all this mean for the future of space exploration? As we expand our reach into the universe, we are faced with an exhilarating possibility: the exploration of a cosmic ecosystem interconnected and teeming with the potential for life. Every new discovery, whether it's the atmosphere of a distant planet or a curious signal from a star system, brings us one step closer to understanding our place in the vast universe. But with each answer, new questions arise. Questions that challenge our deepest assumptions about life, the universe, and everything in between. The search for life beyond Earth isn't just about finding something familiar. It's about embracing the unknown, pushing the boundaries of our imagination, and acknowledging that we are part of a much larger, mysterious cosmos. The future of space exploration is unfolding before us, and it is brimming with opportunities to redefine everything we know about life, existence, and the universe. As we move forward, the discovery of another Earth or signs from an alien civilization may not just mark the end of one chapter. They may herald the beginning of a new, grander story.